Well, if you then reflect on what the implications of these changes are, firstly, there are numerous opportunities, of course, to innovate in these areas, plus the fact that it will transform numerous activities of manufacturing in a dramatic way. So this technology transformation is, of course, critical in that sense, and let me come back to that in a second. The other transformation we see is that the service component of manufacturing is growing dramatically. Because if you think about it, nobody really wants to buy a product, well, there are very few, they are normally collectors by nature. Most of us want to buy the feature, the benefit, the need that the product enables us to satisfy. So we want a camera not because we want a camera, we want a camera because we want to take a picture. We want a mobile phone not because we want a mobile phone, we want a mobile phone because we want to be able to call somebody. So this of course means that we are migrating to a scenario where we actually are buying directly the service. So nobody today really buys a photocopier. What they do is that they have somebody else, normally the manufacturer or their representative, come and put the photocopier in the office, and then you pay per copy, because what you're interested in is the copy, not the bulky machine. So this has forced, on the one hand, and also given the opportunity, on the other hand, manufacturers to migrate into services and also into solutions. They are somewhat distinct, those two. What that means, of course, is that you have companies who are heavily technology oriented, that are very service oriented, and that sometimes in statistic looks like service companies. And that sometimes means that the statistic tends to tell us the wrong things. It tends to say that manufacturing is dying and service is growing. And that is not necessarily right to the extent that the statistics seems to indicate. And let me give you an example of a distribution of labor force in a company based on these two things. So let's take a large, high technology manufacturing firm. Let's take Ericsson, makes telecommunication infrastructure. Ericsson has approximately 98,000 employees working in 180 countries. These 98,000 employees are divided into three big groups. 22,000, that is to say almost 1 in 4, are in research and development. And referring back to what I said about technology, that is obvious. With this enormous speed of development, you need to put a lot of effort into research and development to maintain the leadership that you have or to achieve the leadership you want. The second group is 50,000 people, and they work in services and solutions. So they are the people who provide the ability for Ericsson to give their customers what it is the customer want, not to have to worry about the box. So if this company then has twice as many people in service as it has in production, that means, of course, that it is easy to say, well, it's a service company. But one has to say that without the product, there would be no service. So this is a manufacturing firm that also does services. Now, if you look at that as a service economy scenario, where people say we're moving into the service economy, you have to divide that service economy into three components. You have to divide it into what we would call high quality, sophisticated services. The things done by accounting firms, very sophisticated management consulting firms, investment bankers, and so on. These are the type of service job that people tend to think about when they think about services. They are well paid, they are reasonably innovative, and they attract capable people and are an asset to the economy. The next group, which is very large, are the services that are surrounding manufactured goods. Be that after-sales service, be that repairs, be that the provision of solutions and so on. This is a very large chunk, and that is actually something completely interlinked with manufacturing, and without manufacturing, this does not exist. And it's worth also mentioning that the first group, the very sophisticated one, has most of the customers in manufacturing sectors. Without manufacturing, they wouldn't exist either. The final group are low-paid, frequently part-time service jobs, standing in a shop, doing other type of things. They are actually the least productive jobs in the economy. So if you migrate people from manufacturing to those jobs, for example in the US, annually the gross national product shrinks by 0.3% as a consequence of that reduction in productivity. So if you now reflect back for a minute to the capabilities that a company like Ericsson requires. So they require people in research and development. They require people in solutions and services. And they require, of course, sophisticated people in manufacturing and management. And if you look at that and put that against the general development in migrating up this technology domain in manufacturing, where manufacturing processes were shipped as well as the products and services we produce, we can see that the requirements on working in manufacturing are getting quite high. The amount of jobs that will be very simple, classical jobs that requires no education are disappearing. So you will not be able in the future to get a job in manufacturing unless you have a good education. In a sense, manufacturing is going white-collar workers. That will, you will not bend a piece of steel. You will operate an industrial robot that bends a piece of steel, and we see that already. And tomorrow, you will be operating a biotechnology process that generates that piece of steel through some other means or other. So it is critical that we have a workforce with high levels of education. And those areas of education needs to be in the sciences. And one of the things we are suffering from generally in the developed world, the OECD world, is we are running out of engineers. And it is critical that we maintain and increase the level of education around science. That is to say, from a school point of view, physics, chemistry, biology, and mathematics, because if you think about them, they all link together. Physics is a key domain, and we just heard that we may have had an interesting breakthrough in paradigm shift around questioning whether the relativity theory assumptions are correct that Albert Einstein came up with. And actually, if you think about it, it's about 100 years since he came up with them, and before him he broke the paradigm of Newton, which was about just over 100 years before him. So the cycle makes sense. But physics uses mathematics as its language. And then you have chemistry, which uses both physics and mathematics as its language. And then you have biology that uses all the other ones, in other words, both physics, chemistry, and mathematics as its language. So it's the most sophisticated and complex of the three. But we need people to study these things, these fantastically fascinating areas, and ensure that we have access to these capable people to come in to get higher educations, either at TAFEs or at universities, that provide the basis for the continued growth of our manufacturing industry, which is critical for cohesion in society, which I will return to in a minute. So the responsibility of our teachers and our educational system to ensure that our students, our young children, which are our future, are finding these subjects fascinating, are finding them really interesting, and are committing to study them is critical. And this responsibility cannot be underlined and articulated clearly enough. And I would pass that challenge on to you. And that has also to do with cultural issues, and we have to change those issues. I come from the manufacturing belt in Europe, which is basically the Germanic world. It stretches from Finland and Sweden in the north to Austria and Switzerland in the south, incorporating in Holland and Germany and Denmark and other borderlands around it. In these places, engineers are heavily respected. In these places, you do not want your daughter to marry a lawyer or an accountant, because those are people who failed to get into engineering school. But I have also lived in the UK, and in the UK it's the reverse. In the UK you do not want your daughter to marry an engineer, because those are the guys who have dirty nails, talk with a funny accent, and failed to get into banking. And you can see the difference in the economies reflected in this. The UK went down the route of a financial services industry. It didn't turn out that well, right? All in all, their economic growth rate this year is forecasted to be about 1.5% or so, whereas the people in the manufacturing belt have growth rates between around 4.5% to 5%, in that area. So it is critical, and in Australia, it is very likely that the primary constriction on manufacturing growth in the not too distant future is going to be lack of competent people. And this is something that also rests in the responsibility terms on the shoulders of the employers. they have to spend much more effort on continuously educating their employees to enable these employees to become a contributor to the success of the firm. Let me illustrate that with an example. About 5 years ago, 20% of the components cost allocations in a car related to software and hardware for computers and electronics and sensors. Today it's about 40%. In a couple of years' time, it will be 60%. Now, when it reaches 60%, there will be hardly any single component in a car that will either not contain or interact with a sensor, a piece of electronics, or some software. That means that the sub-supplier who operates in that industry and produces that widget will have internally to have capabilities in these domains. And those capabilities will not come automatically. They have to be trained, so the staff of this firm has to be educated in electronics. That doesn't happen unless there is an investment from the firm and a commitment from the employee to make these things happen. And today, this happens in far too few situations. And the future of Australian industry is not by reducing the cost of its employees, reducing the cost by 20% to hiring a half-literate person. That is not going to work because they will not be able to contribute to the firm. It's a dead end. You are a high-cost manufacturing environment. Welcome.